For the purposes of being consistent with what's presented in our textbooks, I'll be breaking up the eras into the first and second industrial revolutions. The first industrial revolution, there's some debate over the time period. I'm going to go with 1760 to about 1840, but you will run into some historians who will come up with different dates or use other events, different events to denote when these revolutions begin and end. And as I mentioned too, there are some historians who take issue with the whole idea of periodization or trying to create these eras. This is a time period, though, that is known for increased mechanization or greater use of machines in production. It's known for improvements in transportation. Roads, railroads, and canals begin to connect cities and regions on a much greater scale. And finally, there are significant improvements in iron-making technologies that we'll talk about. There are a number of reasons suggested by historians for the emergence of the industrial revolutions. One theory suggests that the end of feudalism and the shift to modern capitalism played the predominant role. Other historians will look to events like the enclosure movement, in which landowners began to fence off or wall off land that had once been common lands. This forced people off the land because they could no longer gather firewood or collect water or hunt or fish, and they had to go to cities to seek work. Others point to the British agricultural revolution, which was an increase in agricultural productivity in Great Britain from the 17th to 19th centuries. Surplus food that was produced by the agricultural revolution could support a much larger population, meaning, of course, more laborers who would work at lower wages, and industrial concerns needed that labor pool. Colonial expansion definitely played a role. There were now more markets for trade goods, European trade goods, and new access to raw materials from some of the places Europeans traveled to. Technological innovation certainly plays an important role in that. You can't have an industrial revolution without some of the inventions that we'll talk about later in the lecture. And finally, the role of capital in the form of wealth from the New World. The Americas played an important role due to this influx of wealth from the Americas and also Africa and Asia. Europe was the wealthiest region in the world at this time, the late 18th century. High levels of capital meant more money for investment in industrial production. James Watt is often credited with inventing the steam engine. We should note that he did not actually invent it, but only made practical modifications of steam engines that were existing for industrial uses. The ancient Greeks really were the first to experiment with the concept of steam engines. The steam engine, in its more modern forms, was initially designed to pump water from coal mines, enabling coal mines to be deepened beyond groundwater levels. This is an important technological innovation. Perhaps even more important was the development of new steel-making techniques. Benjamin Huntsman was a clockmaker who was in search of better steel for his clock springs. In 1740, Huntsman developed a system that used a coke-fired furnace that could reach temperatures of 1600 degrees Celsius, into which would be poured into these clay crucibles. That's where we get the word from. About 15 kilograms of iron. The term crucible refers again to the container used in the process, which can withstand extremely high temperatures. When the pots or the crucibles became white hot, lumps of iron ore treated with carbon would be put inside, and flux would be used to remove impurities from the treated iron. The pots would then be removed after about 3 hours in the furnace. The impurities would be skimmed off, manually skimmed off, and molten steel would be poured into molds that are known as ingots. Before the introduction of Huntsman's technique, the town of Sheffield in England annually produced about 200 tons of steel. A century later, that amount had risen to over 80,000 tons per year. So that's 400-fold, and this represented almost half of Europe's total annual steel production as the 20th century emerged. The discovery of this process enabled the city of Sheffield to develop from a very small township into one of Europe's leading industrial cities. Its population spiked from about 60,000 people in 1800 to approximately 500,000 people by the end of the 19th century. Another important invention in the first industrial revolution was the spinning jenny. The device was invented in 1764 by James Hargreaves in Lancashire, England. The name spinning jenny likely is derived from the word engine. There are some theories, mostly discredited, that Hargreaves may have known a young woman or a child named Jenny, and that's what he named it after, but it seems most likely that this is etymologically related to the word engine. The spinning jenny greatly reduced the amount of work needed to produce yarn. The first jenny had 8 spools, so one operator could do the work of 8 people without the jenny. Interestingly, children made excellent candidates to work the spinning jenny given their smaller hands and nimble fingers, and the spinning jenny is sometimes associated with the rise of the use of child labor in industrial settings. The machine was also quite simple to operate, unlike the relatively skilled labor traditionally involved in spinning thread or yarn with a traditional spinning wheel. Spinning jennies eventually emerged that handled up to 120 spools as technology advanced. The 19th century saw the rise of the large-scale factory, and this innovation is closely associated with the first industrial revolution. The factory gathered together large numbers of workers in one setting, ensuring more efficient production. A factory was thus easier to administrate, and workers could be moved from job to job in the facility, meaning fewer expensive artisans. Factories also gave their owners the ability to mass produce more goods at lower costs. The changes brought by the first industrial revolution were most definitely noticed by people of the time, and the emerging industrial structures were frequently criticized. Industrial innovations led to widespread use of child labor. In general, there was a significant lowering of wages as skilled workers were replaced by machines and unskilled workers. The elimination of artisans and craftsmen also led to a decrease in the number of people who actually possessed the knowledge associated with these various skills. In general, the first industrial revolution increased unemployment, especially among skilled workers. Factory settings often meant very long work days. Workers typically complained of a pace that had been set by machines instead of by the more natural human rhythms. Another frequent criticism was the dehumanization of modern work. People were no longer valued for their skills, but instead were treated as easily replaceable cogs in a giant factory machine. Criticisms of modern technological innovations took a somewhat violent form in the Luddite Movement. The Luddites were a loosely organized group of 19th century English textile artisans who protested against technological innovations that emerged in the first industrial revolution. The Luddites recognized that these new machines meant that skilled artisans could be replaced with less skilled and lower wage laborers. The Luddites were named after a fictional character named Ned Ludd, a mythical figure who, legend held, destroyed machines in protest. He'd be kind of akin to maybe a John Henry or a Paul Bunyan sort of figure in U.S. history. The movement seems to have started around 1811 in England. It's unclear just how many machines were destroyed, but the British government aggressively cracked down on machine breakers, with attacks on industrial equipment being made crimes punishable by death. This suggests that the Luddite actions were fairly widespread and definitely perceived as a threat to the industrial order that was emerging. Dating the Second Industrial Revolution also was somewhat problematic, especially since some historians of technology dismissed this idea of two separate revolutions. And again, when do you start a revolution? When does the other revolution end? We're going to go with 1860 as a start. Generally, the era by most historians is defined as beginning with the introduction of the Bessemer steel process in the 1860s and ending with the emergence of assembly line industrial production in the early 20th century. New industries emerged in this time period that had profound effects on a wide range of human activities, not just industrial production. The industries that became important in the Second Industrial Revolution involved such spheres as electricity, steel, transportation, and chemicals. Transportation innovations included the emergence of vast railroad networks, plus the inventions of the automobile and the airplane. In addition, the Second Industrial Revolution is noted for the development of heavy industry, or simply put, the production of machines that make other machines. The emergence of assembly line production is another significant innovation. While Henry Ford is often credited with this innovation, his most significant improvement to the concept of the assembly line was in having workers remain in one place while the vehicle was mechanically moved from worker to worker. The Bessemer process is named for one of its inventors, Harry Bessemer. There was some dispute at the time over the patent in large measure because several inventors happen to be working on the same idea at the same time but in different parts of the world. And this happens fairly regularly when there is technological change happening. We've seen it most recently in some of the software and digital technologies that have emerged. And I just find it very fascinating, the idea of independent but simultaneous invention of similar products. But at the same time, it makes a certain sort of sense because if there's a problem to be solved, in this case, in the Bessemer process, how to make and more efficiently make steel and of higher quality, then it's not surprising that many people would be working on it because it could represent a lot of money. Anyway, the key innovation in this particular process is that impurities can easily be removed from iron ore by forcing air through the molten iron. In the Bessemer process, pressurized air is blown into the bottom of a furnace. It's known, the technical term is a converter. You can see it on this image that accompanies the slide. The bottom of the furnace contains molten pig iron. The leftover carbon in the iron burns out. Carbon is added to the iron ore to make steel to strengthen it. Other impurities form waste material known as slag, and you can see the slag is collected at the bottom there. The furnace is emptied by tilting the device, and the molten steel is poured into ingots or whatever casting device is being used. The Bessemer process revolutionized steel manufacturing by decreasing its cost significantly. The new process produced steel that was 60 to 80% cheaper than existing methods. The Bessemer process also increased the scale of steel production as well as the speed of steel production for global industries, and the labor requirements for steel making sharply declined. Experiments with electronic transmission of information date back to at least 1792, but Samuel Morse widely gets credit for developing the concept of a single-wire telegraph system. Similar competing systems were again simultaneously being developed by other European and American inventors. The legal battle, which was really ugly, over the patents and the rights to the telegraph was lengthy and complex. However, for our purposes, the telegraph dramatically reduced the amount of time that it took information to travel long distances. The first commercially viable transatlantic telegraph cable was successfully finalized in 1866. The telegraph expedited the growth of multinational organizations because they could trade information back and forth relatively quickly. It reduced information costs within and between firms on a scale previously unprecedented. If you can think, prior to this time, information could only travel as fast as a physical medium could deliver it. A human on a horse, a human on a bicycle, a human in a railroad train. I guess the closest parallel to the ways in which human interaction was changed by the telegraph would have to be the late 20th century advent of the internet. Interestingly, too, also journalism changed with the telegraph because language became more standardized between journalists. Information could flow freely, much more rapidly than it had been. Dispatches from around the world might take weeks to travel from say, East Asia to London, or a week or so to get from the United States to London, and this time was dramatically cut shorter. The ideas behind the internal combustion engine date back thousands of years. There were many competing claims in the 19th century for the title of the inventor of the internal combustion engine, and like the telegraph, many inventors in different parts of the world were simultaneously working on the same problem and developing similar types of engines. In 1860, a Belgian inventor, Jean-Joseph Etienne Lenoir, Lenoir, developed the first gas-fired internal combustion engine that could be reproduced. In 1862, German inventor Nicholas Otto, who's pictured here, was the first to build and sell an internal combustion engine on a commercial scale. By 1876, Otto, who partnered with Gottlieb Daimler and Wilhelm Maybach, developed a four-cycle engine, while by 1879, German inventor Carl Benz had developed a two-stroke engine. So you're seeing some of these names, Daimler and Benz, and you're making the connections, I'm sure, to modern automobile manufacturers. The internal combustion engine, though, for the purpose of our class, provides a comparatively efficient source for power that far surpassed existing modes of producing power. Humans rapidly expanded the geographical range in which they could function by using vehicles powered by internal combustion engines. The rise of suburbs and exurbia is directly connected to the emergence of gas-powered vehicles. Prior to this time, cities used to be concentrated, with the city center being sort of the place where the wealthy were. And in just a matter of decades, suburbs became the place where the wealthy went to get away from the poor. That might be a little bit harsh, but that's kind of the way it worked out. If you could afford to move away from the city center because you had access to transportation, you did so. The rise of quite a few industrial and commercial devices is directly connected with the addition of internal combustion engines that powered them. And really, few inventions have had as profound effects on human life as has the internal combustion engine. Henri Nestle was a German-born inventor who changed his name to better appeal to French consumers. At the time, the French and the Germans weren't getting along, although when you think about it, there haven't been that many times in which the French and the German have gotten along particularly swimmingly. Nestle got his start actually with infant formula. He combined cow's milk with a grain like wheat, plus flour and sugar, to produce kind of a substitute of mother's milk for children who were not able to breastfeed, who were born with the inability or for whatever reason they would not latch. Prior to Nestle's invention, such children frequently died within days of birth unless they were able to find a nursemaid. Nestle and his partner removed acid and starch from the wheat flour as they perfected their formula, because these are items that are difficult for babies with new digestive systems to consume. The product was especially appealing because it was prepared simply by adding water, and generally it's considered to be the first true infant formula. Nestle and his companies, as he developed further innovations, were leaders in mass production of food for human consumption. Now, the idea of canning food or preparing food for long periods of preservation was not new. He didn't invent that, but the mass production of canned foods was his innovation. Interestingly, his innovations also kind of unwittingly helped military officials plan lengthier campaigns, since they could store greater amounts of food for more extended periods of time. Finally, warfare, like other human activities, became much more mechanized as a result of the industrial innovations and the industrial revolutions. Perhaps no device better represents the greater efficiency and mechanization of war, more so than the machine gun. The Model 1862 Gatling gun was a hand-powered machine gun, and its chief innovation was the gravity feed reloading mechanism, which generated a rate of fire of about 200 rounds per minute. More importantly, the machine gun could be operated by personnel who didn't have very much training. You could, in a matter of an hour or so, teach someone how to operate, clean, and maintain this device. By comparison, the best breech-loading rifles at the time, such as the U.S. military Sharps rifle, so widely used in the Civil War, could fire at best about 10 rounds per minute in the hands of an expert marksman, who, of course, had many, many hours of training to learn how to shoot his weapon. Warfare, like the greater efficiency found in industrial production, could be fought at a much greater and deadlier fashion than ever before. This brings to a close our brief look at the industrial revolutions.